Okay, welcome to Chapter 1. You might want to go ahead and make sure that you have a pencil, a sheet of paper, and a calculator nearby. And I also want to say up in advance, feel free to pause whenever you need to either read more carefully or to perform some of the problems that we're going to be doing together. Tonight's topic is variables, and I want you to notice the decimal number 1.1 that goes along with the topic. That 1.1 stands for Unit 1, Section 1, and it will also match up with the exact same decimal number in your textbook. So if you ever need extra practice or a little bit more help in terms of studying before a test, you don't have to rely solely on these videos. You can also utilize the textbook. And when we definitely get into more difficult material, you're going to need to do that. Okay, so let's go ahead and hop right into it. We've all worked with variables before. We always want to define what we're talking about. So a variable is a symbol that is used to represent one or more numbers. And typically when we think of these symbols, we are talking about letters, X, Y, A, B. Although they do not have to necessarily be letters of the Roman alphabet, sometimes we also employ symbols from other languages, particularly Greek, which we'll see here in a few minutes. Variable expression, a collection of numbers, variables, and operations. This concept of expression is really important. I definitely want you guys to understand exactly what an expression is. So I like to think of it as just like mathematical stuff. And it's stuff that's just floating out there by itself, and it's joined together by operations. So stuff that's joined together by plus, minus, times, divide. And when I say stuff, we're talking about variables and numerical things. So for example, let's look at the difference between an expression and what we commonly confuse it with. An expression would be something like 3x plus 7. Okay, standing alone by itself, we would consider that an expression. What we don't want to confuse that with would be something like this. 3x plus 7 equals 22. Now that we would not call an expression. That's what we refer to as an equation. What's the major difference between the two? Well, with an equation, we have an equal sign. And we actually have two expressions, one on the left-hand side and one on the right-hand side. So expressions do not have equal signs, equations do. And you will be expected to use the appropriate terminology in the class. So make sure you understand the difference between those two things. Okay. And then finally, evaluating an expression. That's a really important term, evaluate. Evaluate basically means that we are going to plug in the values for the variables. So we evaluate expressions, but we don't use that term with equations. For equations, we don't evaluate. For equations, we solve. All right, to give you a couple more examples of expressions, all of the following are expressions. 2 plus x, 9 minus y, 12 divided by a, and 8 times y. And notice none of those have equal signs. Expressions don't have the equal signs. Okay. Typically, we won't, we won't write 8 times y like this anymore. That might be something you would have done in 4th or 5th grade. And usually we prefer something like this, where we're just putting the numbers right next to the variables to imply multiplication. So here we have 8y. This is sine theta. Theta is one of those Greek letters that just implies that we're talking about angles. And then PRT, that's P times R times T. Principal times rate times time. That's the simple interest formula that some of you might have worked with in middle school. Okay, so let's get into it. Make sure you have pencil and paper. You're actually going to do these on your own. I want you to copy down these 4 problems. You'll turn these into me tomorrow in class. That way I know that you've written the video. So now would be a good time to evaluate the expression when y equals 3. You can go ahead and pause the video, go ahead and perform these, and then we'll go over answers in a second. So now would be a good time to go ahead and pause. Okay, let's go ahead and take a quick look here. 8y. Something that's very important whenever we're plugging in variables, always plug in inside parentheses, especially if we're dealing with multiplication. So you don't want to write 8 and 3. That would look like 83. It's got to be 8 times 3. Those parentheses are going to show us that. So whenever we're connected by multiplication, got to plug in inside parentheses. All right, 8 times 3 obviously is 24. So I know that you guys all got that one right. All right, 15 over y. That's going to be 15 over 3. And here you don't necessarily need the parentheses because that fraction bar kind of separates the 2 numbers and it protects you. So 15 over 3, that value is 5. All right, y plus 7 we would rewrite as 3 plus 7, and that is going to be 10. Once again, you don't need the parentheses because they are protected by the plus sign. It kind of separates the 2. But if you wrote the parentheses, I have no problem with that. It's kind of safe to write those parentheses if you're not sure. Here we have 14 minus 3, which is 11. So nothing too tough there. Okay. So in some of your work to follow here, you're just going to be evaluating variables. That just means plugging them in. Another aspect of the work that you're going to do with this unit is unit analysis. You can go ahead and read this quickly to yourself. There's a lot of different levels of unit analysis. You're going to do this on a more technical level in your science classes, but for today, really we're just going to worry about using common sense. In other words, you should be able to read a word problem and know, okay, my answer should have these units. And usually you do that through common sense or looking at certain keywords. So go ahead and read this guy to yourself. When they ask you how long will it take you to get there, that phrase how long implies that we are dealing with time. Okay, so your answer should be related to time, and your answer is going to be in hours. Okay, now most of you just kind of know how to do this problem, but sometimes we do get confused if we multiply or if we're supposed to divide. So anytime we're dealing with one of these distance problems, we use an important formula that you're going to need to know. So d equals r times t. And go ahead and think about what those variables might stand for. The d, we are going to say, is distance. The r, what do you think the r is? The r is rate. It's like your speed. And then the t, that's correct, it's time. And this will always allow you to set things up correctly. So distance equals rate times time. If you go back to the problem, well, let's look at that 115 number. Okay, 115 miles, that is going to be your distance. So you can always set it up with a 115 plugged in for distance. Okay, 75, it says 75 miles per hour. That is your rate. So you know your rate. In this case, you actually do not know your time. So the t is the one outstanding variable. And every time we have one variable left, that's precisely when we can use algebra to solve for it. So we have 3 variables, we know 2 of them. The third one we should be able to work backwards to figure out. And you guys all learned how to solve one-step equations. What would we do in this case? Well, if we want to figure out what t is, we have to isolate the t. You're going to divide both sides by 75. go ahead and take your calculator, go ahead and divide 115 by 75, see what you get. I believe you get some sort of decimal number. I'll go ahead and do the same thing. 115 divided by 75. Okay, and maybe we could round that. So t is going to equal 1.53. And then what would our unit be? Well, if it's time in this problem, time is talking about hours. So 1.53 hours. Okay, so go ahead and try this one on your own. You can pause it if you need to, and then when you unpause, we'll go over the answer. This is another this is another D equals RT problem. Distance equals rate times time. But this one I think will be missing a different variable. So we know, let's see, the average speed if you traveled 450 miles from Phoenix to Bryce Canyon. So our distance is 450 miles. Okay, now we don't know our rate, we know our time. We know that the time is 8 hours. So R is still left as R. The time is 8 hours. So this time we're going to be solving for R. And you would divide both sides by 8. Those 8's cancel. And using your calculator, you should get R equals something like 56.25. But it does say round your answer to the nearest tenth. So that 56.25, you would need to round to 56.3, just because we're going to follow those directions. And we're talking about rate, so the rate here is miles per hour. And notice mathematically, per is division, miles divided by hours, so miles per hour. All right, very good. That's example 2. Let's go ahead and we'll go to our last example, example 3. It's reminding us that we have a formula for simple interest, and that's I equals PRT. Interest equals principal times rate times time. Okay, which we'll need to know to be able to solve a problem like this. It says you deposit $800 at a rate of 6% per year. How much interest will you earn in 2 years? How much money will be in your account at the end of 2 years? So why don't you go ahead and try the formula on your own. Once again, we're evaluating by plugging in what we know for these variables. That's the skill. Go ahead and hit pause and try this on your own, and then you can unpause it. We'll go over the answer. All right, if you didn't get that before, the I equals PRT, you have to know what that all means. So I here stands for interest. My handwriting is not very good yet, but I'll get better. P stands for principal. And the principal is basically the starting amount. R stands for rate. And T stands for time. And so now we're dealing with 4 different variables. Hopefully we're going to know 3 of them. And if you know 3 out of the 4, we'll be able to work backwards to figure out what our answer is. Okay, so let's just take these one number at a time. It says you deposit $800. So do you think that that's the I, the P, the R, or the T? Well, it's your starting amount, so that's going to be your principal. So we might begin with I equals 800. Okay. Now the rate, it does say that our rate is 6% per year. You cannot use percentages to do computation though, and you guys remember from middle school you're going to have to change this number to a decimal. So what is 6% as a decimal? Well, you move it 2 places, 0.06. Okay, so your rate is 6%, but as a decimal, it's 0.06. And that's the number we always use to actually do math with. And then the time, you won't see the number, but it's in there in print. It says 2 years. So our time is going to be in years, so 2. And we're multiplying all of those values. So if you go ahead and use your calculator right now to multiply, you're going to find out that your simple interest is, I believe, $96. And that answers question number 1. How much interest will you earn in 2 years? Okay. Now the second question, how much money will be in your account at the end of 2 years? It's a very different question. You started with $800, so it wouldn't make sense to have $96 in your account. You're going to have to add that 96 onto the $800. So there's an addition process there. $800 plus the interest you've earned. At the end of that first year, you will have $896. Okay, so this gives you a good idea of the type of work you'll be doing in your assignment. Feel free to go back and redo these problems on your own, but you do need to have work for all examples 1, 2, and 3, to turn in during class tomorrow. All right, signing off. Good job.